No, as the body A is losing heat, a point is reached at which the heat flowed from A to B will stop when two of them have the same amount of heat energy. The temperature at that time, at that equilibrium stage, is called the final temperature, steady temperature, or equilibrium temperature. We use theta S to represent the steady temperature, a point at which equilibrium state is attained. So we have steady temperature represented by theta S, steady temperature, which is the same temperature for A and B at that particular time. Having said that, it is now very clear that the heat lost by A, because we know whether a body loses or gains heat energy, to know the amount of heat energy gained or lost, we use MC theta, where theta is the change in temperature. So the heat lost by A will now be MC theta for substance A must be equal to MC theta for substance B. But here, there's difference in the MC thetas. Let's look at it. M for A represents the mass of A. C, specific heat capacity of A. I'm writing M subscript A to show that it's mass of object A. C subscript A to show that the specific heat capacity of A. Then I can write change in temperature of A. A had a higher temperature. By losing heat, the temperature will fall to theta S. So it's going to be the initial temperature of A minus the steady temperature. The heat gained by B will be mass of B, specific heat capacity of B, change in temperature of B. The temperature of B, having gained heat energy at this stage, will be more than the temperature before. So it's going to be the steady temperature minus the initial temperature of B. With this very equation, where there is a case where heat is lost or gained, we'll be able to determine any of these values that is not provided.